Yo guys, what's up? So welcome to another video. So this one we'll be looking at non-uniform rods now, and the idea is to find out the distance from A for where the center of mass could be. So in other words, we don't know where the center of mass is for any uniform rod, but we're gonna apply some special technique I use to always get it right. So without further ado, let's go. So before I start, this is from example 11 from page 127 of Pearson's Mechanics M1 book. So if you haven't already purchased it, I recommend you go out there to stores, go on Amazon and just hook yourself up. Trust me, definitely hit it up. So now suppose the question told us that this rod is 3 meters long. We have a reaction at C, which is 1 meter from A, and a reaction at D, which is 2.5 meters from A or 0.5 from B. Suppose now we know that the magnitude at the reaction at C is 3 times the magnitude of the reaction at D. What this means is, wherever the reaction at D is, we know RC is 3 times bigger than D. Literally that, dead easy. Secondly, suppose we don't know where the hell the center of the mass is. My rule of thumb is to always say what the hell, let's just say it's in the center, but not call it that. It's a safe location, and because we don't know what the value is, we always give this a value of from A, X meters away. This is it. I mean, once you find the value X, you can exactly pinpoint it, but for a rule of thumb, just pick the center as, a pseudo center of mass. Okay, so now without further ado, all you're literally doing here is resolving. And oh yeah, of course, the bar itself is 20 newtons, so this center mass is 20 newtons, yeah? So of course everything needs a weight. Alright, so now all we're literally doing is resolving, so this is going to be dead easy. So resolving upwards, what do we have? We sum up the top set, so we've got 3RD plus RD. Well, I'll just write it down step by step. And I would subtract the bottom minus 20, say 20 newtons, and this equals 0. Because it's in equilibrium. And of course, dead easy. So these two, sum up these two, you get 4RD. Put 20 on the other side, subtract both sides by 4, you're going to get RD equals 5 newtons. Simple. That was quite simple, wasn't it? So now let's look at the bigger picture here. So now we care about is now we want to take moments to find the value of X. So using A as our starting point, we always use A, by the way. And when you work upwards, I mean, I always say this is going to be a positive and this is going to be negative because of the equilibrium rule. Because the idea is that the sum of the clockwise moments always equals some anti-clockwise, and given that upwards is anti-clockwise, downwards is clockwise, it don't really matter what the hell, because you're going to get the same values. You could put this in negative and this is positive. I think for mental sakes, easy to make this positive and this one negative, because you're always doing forces. So without further ado, let's jump in. So the way this works, moments is always distance times 4. So taking moments about A, or starting from A, we've got 1 times 3RD, which is 3RD. Plus this distance, of course, which is 2.5 times RD, which is plus 2.5 RD. Now working downwards, we only have 1/4, so it'll be A to 20D, so distance of X times 20, which is 20X. And all of this, thankfully, equals 0. Now literally plus, now this is just an easy case, so adding up these two and replacing RD with 5, we have 5.5 times 5. This should give us 27.5, and then plus this across should give us 20x, and dividing both sides by 20, this should give us a nice x equals 27.5 over 20, which is exactly 1.375 meters from A. And yeah guys, I mean, that's really it for non-uniform rod. I mean, the general idea is to just place it in the middle, give it a distance for x, and that's the only difference. Dead easy, really. I mean, if you know uniform, you can't go wrong with non-uniform. Just try and make the distinction that uniform means everything is center, but non-uniform means the mass could be anywhere. According to this one, it's more close to 11. The real distance is here, 1.375. But yeah, I mean, at the end of the day, we got this, and it's just a sketch. So guys, if you got any more non-uniform questions, or you want to hit me up with anything else, just let me know, and we shall bang it out. Anyway guys, take care, and I shall see you soon. Ciao, ciao.